Joaquin Guillen, and I'm coming from Glowing, a Spanish startup company. I'm presenting a paper which more or less summarizes the work that we're doing currently, developing a product in cloud. And the work the paper was written by myself and Javier Miranda, who's here with us today as well, Juan Manuel Murillo, and Carlos Canal, who's a professor from the University of Málaga. The good thing of being one of the last ones to present is that a lot has been said already about all of the problems related with cloud computing and everything, so I'm not going to go into much detail about that. But basically, just to put into position this work, say that cloud computing has become one of the latest phenomena, and a lot is being said about cloud computing, and many companies want to migrate their applications to the cloud. And depending on the nature of these companies, they will want to migrate to cloud for one reason or another. Companies, I don't know if you sit with the iMac, but companies like Facebook or Dropbox that offer very simple services will always be looking for scalability and the availability of their services. They want to have constant uptimes, therefore migratability to other providers may be important if their cloud providers go down. Whereas other companies, such as banks, insurance companies, will be looking into cloud in order to limit their costs and will most often not migrate all of their systems to cloud, but only some parts of them. And therefore, interoperability with the cloud will always be an issue. So if we want to really take advantage of cloud computing and be able to develop the applications that Dan and ourselves spoke to us about before, where we can actually have cross-cloud applications that interoperate with one another, we have to consider whether this is actually easy. And the answer is that it's not. As we've been able to see this morning, there's different APIs used by the providers, and it's difficult to actually get things working at start if we don't have a good technology that allows us to do so. So to solve this, there's been different standardization attempts. We've also seen some of them during the day, so I'm not going to go into detail. But we think that the problem about standardization is that, at least for now, it doesn't seem like a short-term adoption of standardization is going to get there. And that, after all, we don't know if there's going to be any final consensus on standardization, or whether standardization will give us application migratability, application interoperability. So we may even come up with the problem of coming up with different standards, which would actually give us interoperability issues between different standards themselves. So we think that we have to try to go further than this and come up with alternative solutions that will allow us to get where we want. And an alternative to all of this have been the middleware-based alternatives that have been gathered in many works. Whereas, we create an abstraction layer between the clouds and the applications, so that by providing a middleware API, we manage to applications interact with the API, and therefore can be migrated easily to one cloud or another, because the middleware takes care of the integration of the cloud. And these are very robust solutions, are completely valid. But we propose an alternative solution based on the use of adaptation. Okay, so the solution that we propose is basically divided into three different phases. Where in the first phase we model the application that we're going to develop. In the second phase we code the application, and in the third phase we generate what we will call, and we'll explain what they are, a series of cloud artifacts that can finally be deployed to one cloud or another and interact with one another as well. So in the modeling phase, what we've, if we look at, for example, an application that has been modeled as using a component diagram, what we've done is that we managed to group these components into what we've called cloud artifacts. Okay. Cloud artifacts will basically be groups of components that will finally be deployed in cloud environments, taking into account that each cloud artifact will contain a series of components where communication between the components themselves will be done locally when they're inside a cloud artifact. And however, when components are found in different cloud artifacts, well, we'll have to communicate these components remotely, and therefore we'll have to provide some sort of mediation between them. So we model our applications this way, and we also consider that they can also communicate with external services. Well, at the end, what we'll be able to generate is a transformation of these models to an initial cloud deployment plan, where we'll state how to break down our applications and how and which parts of our application will initially be in one cloud or another. Okay, so this cloud deployment plan would be taken as an input to the next phase, where we'll try to enhance the plan, and we'll first of all start coding our application and coding all of the logic of our application, and second of all, we'll provide a series of tools in order to, based on where we want to deploy our application, continue to configure and enhance this deployment plan, stating how it's going to be deployed in the cloud. And when I mean how it's going to be deployed in the cloud, well, we'll have to identify the different cloud artifacts that are involved, how artifact to artifact mediation has to be implemented in order to get interoperability between artifacts, and how each artifact will be integrated with the services provided by each cloud provider. And we'll also have to consider how each artifact will communicate with external services. And this is only possible if we have a really good knowledge base of each cloud that we're going to be supporting. And in order to have that rich knowledge base, what we've considered feature diagrams, which are commonly used in product line engineering, in order to gather all of the information that will be necessary in order to be able to do the final deployment. So once we've configured the deployment plan, we'll be ready to generate the final cloud artifacts that can be deployed. And in this phase, what we do is that, starting off from the application source code and taking into consideration the cloud deployment plan that has been generated in the previous phase, well, we can automatically generate a series of, in the first place, cloud artifact projects which comply with the general structure imposed by each cloud provider for their platform. And on the second hand, a series of adapters that will allow us to first of all communicate with the cloud, and as I said before, as well as to communicate with external services and to communicate between one another. Therefore, with this, we can finally have each cloud artifact deployed in each cloud, and without having to consider absolutely from our source code how interaction with the cloud or with other artifacts is done, we'll have those adapters do all the work for us. So this is really beneficial compared to other solutions, because we're getting a really lightweight solution where we're only applying the integration with the cloud and with other artifacts in those places where it's really needed. And we don't have an oversized solution for maybe a very specific case where we're not using all of the logic. And what makes it really powerful is that since we have all the information gathered in a separate deployment plan, our source code is really completely unaware of anything related to the cloud. Anything related to the cloud and even to the technology which it has been implemented with, because, as I said, that's completely separated in an XML file. There's other benefits, but I would like to emphasize the last one as well, where the good thing about this is that cloud providers are really free to choose and to continue to evolve their technology, which without having to consider any standardization efforts, and at the same time, developers are also free to evolve their applications as we like. So in order to conclude, well, I'd like to say that I have a feeling that cloud computing is a really powerful technology that is sort of like a space rocket, which is kind of taking off with a lot of strength, but which is, however, is really low down for now. I think that we continue to think cloud computing, and we continue to imagine cloud computing, giving it exactly the same use that we've always done with technology. And I'm really glad that during these 2 days, the terms of swarm intelligence have come up, like today. The terms of collaborative environments have come up, because I think that that's the real strength that cloud computing really gives us, and it's really its differential values. But the problem is that we don't have technology that allows us to actually exploit that part of cloud computing. So really working on tools that really will make us get closer to that type of technology, I think is where cloud computing is definitely going, and where it's really going to be differentiation. It's going to be very differential in comparison, for example, with the grid. So that's the idea behind the product that we're working on, where this, which I presented today, is found, and we're also working on collaborative environments, and well, yeah, and it's the idea that is our main motivation. Okay. And well, finally, to conclude, we'll say that we're here we're Spanish, so we're here in Finland today, well, because we're considering actually opening up in Denmark, for example. And well, we think that the Nordic region is really interesting for us to evolve this product, to find possible partners that may be interested in this technology and are willing to maybe go on a joint venture with us with this technology. And well, more than anything, because we know the deep strength that cloud computing has here in the Nordic region. We're familiarized with the culture. I personally lived in Denmark, so that makes it easier as well. And also with the way of life and how things are really done in Nordic countries, where excellence is really an important factor in all the products that are produced. So that's a little bit the reason why we're here and what we need to tell you. And yeah, well, that's all. The presentation is available online, so if no one wants to access it, you're welcome to. Any questions?
You should send us the link if you want to download.
Absolutely.
Any questions? I have a question myself. You said this is a product.
Mm-hmm.
So you're presenting a company, the NimBees.
Mm-hmm.
What's the state of the product?
It's currently under development, and one of the things I would want to do is that if we finally, by the time we open up, we'll start really like finishing that development in Denmark and getting people applied from the Nordic region into that project.
So you have not tested it in any project at the moment?
No, we've done very small tests and during development.
Mm-hmm.
How do you decide which component should be deployed on
which component goes where, right?
Yeah.
Well, that's
so that according to the is it according to the consumer's preference?
exactly.
Or,
That's completely an architectural decision. What we're trying to allow is to give you that possibility. Because nowadays, if you really want to do cross-cloud, it's very difficult. And not only that, you may achieve it, but at the very moment that you want to really change the location of two of your components, or you pretty much have to redeploy the whole application all over again. So yesterday, someone came up with a topic about really getting communication between different components. Could be very costly because of communication, the network being slow or whatever. And that's true, but it also depends a lot on the application, on the needs that you really have, and it's really an architectural decision to see if you really need that or not.
So do you have any guidance for the decision making and the product?
Guidance as
guide the consumer to make this decision making.
Oh.
Or you
Yeah, well,
develop
inside the
it?
company, as I said, we do software engineering, so we were software architects as well.
So you make the decision in the company?
Yeah, we have enough knowledge as to develop systems where we can actually identify the need for these sort of architectures. And in any case, that's just a possibility that the tool will give you. Because after all, what we can also give you is to deploy your application in a single node and be able to migrate it or scale it to other nodes accordingly as well, without having actually interoperability between artifacts as such. So it's as I said, it's an architectural decision.
So it's not only between cloud to cloud, actually, it is on the same node or
Yeah.
from virtual machine to virtual machine.
Exactly.
Because we have been thinking about the same a lot in Linux, which should be running where.
Mm-hmm.
So it's kind of decision for migration, like which components should be the same.
Absolutely. It depends on the requirements of the application. So it's especially interesting in as I said, for collective intelligence for those type of applications, because it's interesting to have different instances of the same component deployed all over the world in different clouds. So to that extent, it really gives you a lot of opportunities.
We should consider coming into one of these European projects.
Well, we're actually very, very interested as well.
Yeah, just two short questions. What will be the licensing model of the tools you're going to release?
Okay, the thing is, we have considered the licensing model, as I said, but we consider that on the first place we want to develop a product which will allow developers to actually create these applications in the first hand. So we're considering the licensing for that as a product. But we also want to provide this as a service, because after all, we also develop software inside our company. And as I said, we have a lot of knowledge on architecture, which will help our customers. So, and we have, up till now, we have identified the different models, but we still haven't come up with a whole plan of licensing for the product. It's also something that, as I said, we're looking for partners, so it's also something that we would have to discuss with the future partners.
Yeah, it's good to come into one of these newly started projects actually as a tool.
And that's my second question.
Yes.
Was when in your slide at some point you have this cloud that discussed to another cloud through latter, and so at some point if you push the concept to the end, you'll have like a spaghetti of different clouds and adaptation. Did you provide through the platform or the tool? And I thought I understood you at the code level, so you're already coding this communication and that supported, which is actually awesome. But is there any way to analyze and reason on those interconnection of clouds in the context of a given application?
Analyze the...
If, for example, you can do static analysis that this component is hosted in cloud A and this component is hosted in cloud B, and that from a code analysis on the software, not on the deployment cloud, you can identify that this is a very high throughput link between those two. So putting those two components on two different clouds, it's just the baddest idea that one can have. Is there any way in the platform to support this kind of query?
Our latest ideas are actually, this is the base of the work, and we're looking really to enhance that idea and go even further. And that's precisely one of the things that we're really considering. Actually evaluating how good the deployment is and how good we've actually found it, and try to be able to say, well, now I want to test this out in an optimal environment, or even gathering what your requirements, your quality of service requirements really are for the application, and being able to map them in a real environment and see if it really complies with them. We don't have anything with a lot of work into that, but it is what we're currently looking into.
Thank you. We are behind our schedule, so if you have anyone has questions, we can have it in the break. Thank you very much.
Thank you.